Welcome back to Mr. Hassan's Maths channel. Now this question is question number 5 from the June 2023 International A-Level Edexcel Mechanics M1 exam. This question here is about speed time graphs, and we're given the speed time graph which is already drawn for us, and it tells us about the motion of a car traveling along a straight horizontal road. Time equals 0 seconds. The car starts from rest and accelerates uniformly for 30 seconds. So the acceleration is given by the gradient of a speed time graph, and we can see it has a constant gradient, so the acceleration is constant. Okay, for 30 seconds until it reaches a speed of v meters per second. We don't know the actual speed, it's given the symbol v. It says the car then travels at a constant speed of v meters per second. So we can see that the gradient is 0 here, so it's going at a constant speed because the gradient of a speed time graph is acceleration. So it's not accelerating, it's going at a constant speed of v for 30 seconds until it reaches t equals time equals capital T. Show that the distance traveled by this car between t equals 0 and t equals capital T is v times capital T minus 15 meters. Okay, so now we know two things about a speed time graph. Okay, one of the things I've just mentioned. Okay, speed time graphs, we know that the acceleration is given by the gradient of the graph. Okay, and the second thing we know is that the distance traveled is given by the area under the graph until the time axis. The area under the graph, that's the distance traveled. Okay, so that's those two things we know. So we're going to use this second fact here to find what we're looking for. All right, so we're looking for the total distance traveled. So the area under the graph is this, in this shape of this trapezium. Okay, it's a trapezium shape, and the area of a trapezium, there's different ways of writing the formula. Some people write a half times a plus b times h. I like to write it as the distance between the parallel sides divided by 2 times the sum of the parallel sides. I don't like to memorize a formula. I like to kind of, think about the concept of the formula, right? So memorize it in a way that helps me understand the concept, and not just random letters. I know h is the distance between the parallel sides of the trapezium, and a and b are the length of the parallel sides. So if we mark those lengths on this trapezium, okay, then what we will have here are the following. We'll have this is the distance between the parallel sides, between there and there, and we have that in terms of v, so that's v. Okay, and this is the length of one of the parallel sides, and we have that in terms of t, that's t. And this is the length of the other parallel side, which is in terms of t, it's basically the same as this length here, which is t take away 30. It's like from there to here is 30, from there to there is, the whole length is t. So t take away this length 30 will give us t minus 30. All right, so this is t minus 30. Okay, so the area, okay, we can say, which is going to be the distance, okay, which we're looking for, is equal to the distance between the parallel sides, which is v, divided by 2 times the sum of the parallel sides, which is the sum of these two, which is t plus t minus 30. Okay, so that gives us v over 2 times 2t minus 30. Okay, and because they say show that, and they're given what it's going to be, actually, we have to try to make sure we show the steps very clearly. So I'm going to take out a factor of 2 from this bracket. So I have 2 times v over 2, and this will be t minus 15. Show that the 2's cancel out, so we're left with v times t minus 15 meters. So there is our answer. We have shown, as required, that the distance traveled is v times t minus 15 meters in brackets. Okay, there's part A done. Okay, that's not too bad. Part B, it says a motorbike also travels along the same road, and it starts from rest at time t equals 10 seconds. Okay, so according to this axis, at t equals 10 seconds, he's going to start. So that's going to be 10 seconds here. All right, so he starts there. Okay, and accelerates uniformly for 40 seconds. The acceleration of the motorbike is the same as the acceleration of the car. So the acceleration of the motorbike will be the same as the acceleration of the car for 40 seconds. So he's going to keep accelerating until time has reached 40 seconds. Let's just say 40 seconds is there. Okay, now because his acceleration is the same as that of the car, okay, then he's going to go with the same gradient. Let me just draw it in a different color. I'll just draw it so that it's like, let's say in a red color. Solid, okay. So he's going to start from at 10 seconds, and he's going to have the same gradient as this other car. So I'll just draw it so that's, okay, I'll move my 40 along a bit so it makes it a bit clearer. So he's going to, of course, reach a higher speed. Just say that's 40 seconds. I know it's not very realistic, but it's okay. It's just a sketch. Okay, so now that's like 40 seconds. Let me make that different. Okay. Okay. So that's like now he reaches that speed. Okay. Which we have to work out, well, eventually probably. All right. So there we have, he's reached that speed. We don't know what that speed is, but he's been accelerating at the same acceleration as this for basically for 40 seconds. So this is actually not 40 seconds. This is actually 50 seconds. Okay. Because he's been moving. All right. He accelerates for 40 seconds. So 40 seconds from when he started is going to be actually 50 seconds. Okay. So I can actually make this maybe a bit further along just to make it a bit more realistic. Okay. Make that 50. And this will therefore go a bit higher. Okay. It has the same gradient as that. And we can make it a bit more so it's going to be clearer. The diagram will be clearer if I do that. Okay. So he's been going uniformly until he reaches 50 seconds. Okay. So that's 40 seconds after he started. He's accelerating until that point. And then it says the motorbike then travels at a constant speed. So he stops accelerating and he's now going at a constant speed. Okay. And that speed is that same speed that he reached for 10 seconds, for a further 10 seconds. Okay. So that's 10 seconds before decelerating uniformly along a straight line until it reaches this speed. Okay. Which is the same speed that car was moving at. Okay, at the end there. Okay, so this is the journey of the motorcycle. Okay, now this is another 10 seconds. So let me draw that one in. Okay, so that's another 10 seconds. So I'll just do it from here. Okay, because I've already drawn that up there. So let's say that's another 10 seconds. So that's another 10 seconds. That's going to be 60 seconds. Okay, and this is going to be the T. All right, so here we have his whole journey kind of broken up into these parts here. So starts at 10 seconds, accelerates uniformly for 40 seconds. So by the time time is 50, he's stopped accelerating. Then he goes for constant speed for 10 seconds and then decelerates uniformly until he reaches a speed of v meters per second at t seconds. So they end up going at the same speed at the same time. Okay, so that's the sketch of the graph. So that's part B, 2 marks. Then it says, show that the constant speed of the motorbike is 4v over 3 meters per second. Now, the motorbike is going at a constant speed and the time when it is going horizontally here, where the graph is horizontal, where the gradient of the graph is 0, it's going at a constant speed. And they're asking us to find what is the constant speed, or show that the constant speed is 4v over 3 meters per second. So in terms of v, we got to find what this speed is. Okay, we got to find what the speed is here. Okay, in terms of v, and show that it's basically 4v over 3. So we got to show what this is. Let me call this point y. Okay, this distance y from there to there. So how am I going to find this? Well, I know that the key to this is the fact that they were accelerating at the same rate. Okay, they're accelerating at the same rate. So we can say the acceleration of the car, as we mentioned, is the gradient of the graph for the car in the time that's accelerating. And I can work that out in terms of v, because the acceleration of the car is going to be between these 2 points. Okay, and this is the point 30v, and this is the point 0, 0. So the acceleration of the car, okay, and therefore of the motorbike, is going to be v minus 0 over 30 minus 0, which is v over 30. So I know that's also the acceleration of the motorbike. Okay, and I know that the acceleration is the gradient of the motorbike's journey as well. Okay, so I know this point is 50, and I've called this point y, and this point here, the beginning of that is 10 and 0. So the gradient of this line must also be the same as that gradient, have the same gradient, which is v over 30. So I can say that y minus 0 over 50 minus 10 is equal to v over 30. Okay, so I can find what y is. So that's y over 40 equals v over 30. So if I multiply both sides by 40, I'll have 40 v over 30. The zeros cancel out, so I have y equals 4 over 3v, which is exactly what we had to show. Okay, so we've shown it. I've shown it up here because of the diagram being next to me. Okay, so I've shown the working for it over here. So I've shown that the constant speed of the motorbike is 4v over 3 meters per second. Okay, so I've shown those steps over here, so that's should be no problem. Okay, so now that's part C done. Okay, so I've done part C. All right, so therefore we can say the constant speed of the motorbike at that point is going to be 4v over 3. Okay, so now I'm going to answer part D of this question. All right, so I think I'm going to use this diagram for part D. Okay, so now it says at time t equals t seconds, the distance traveled by each vehicle is the same. Okay, so basically what they're telling us is that the area under this trapezium, which we know is the distance traveled by the car, which we were told in the beginning of the question was v times t minus 15, which we had to show, and the distance traveled by the motorbike are the same. So if I can find an expression for the distance traveled by the motorbike, and I can equate it to the distance traveled by the car, hopefully we can find the value of t. So it looks like that's what the situation is, because we know the distance is given by the area under the graph. So if I consider this area as one big trapezium and then another trapezium attached to it, okay, for this, I'm talking about the motorbike area, all right? Like I call this part A, I call this part B. So we can look at the area of A first. The area of A. Okay, so you got this trapezium shape here. Okay, in this trapezium, the length of the parallel sides, let's draw them in. Okay, the length of the parallel sides, you've got this length and this length. Okay, and you got the vertical height, which is this height here. Okay, so the length over here is 10. The length over here is between 10 and 60, so it's 50. And the height of the trapezium is 4v over 3. Okay, and in this trapezium, the distance between the parallel sides this time is basically this distance here, which is going to be t minus 60. This is t minus 60. Okay, t minus 60 will give us that. Because this trapezium is like on its side. The parallel sides are vertical this time. So this, from there to there, is basically v. Okay, and from here to here is the same 4v over 3. I'll just keep that written. That's for both of these. That's the height 4v over 3. Okay, oops. Let me just mess with that. Okay, so now, so the area of A is given by the distance between the parallel sides, which is 4v over 3, divided by 2. Okay, I'll just put divided by 2 times the sum of the parallel sides, which is 10 plus 50. 10 plus 50. Okay, and that's going to give us now 4v over 3 divided by 2 is equal to 4v over 3 times 1 over 2, which gives you 2v over 3. That's going to be 2v over 3 times 60. And this cancels with that. That's going to give me 20. So it's going to be 40V. Okay, so the area of this part is 40V. Okay, and the area of B, the second part there, okay, we have the distance between the parallel sides, which is t minus 60, divided by 2 times the sum of the parallel sides, which is 4v over 3 plus v. Okay, that's the area of B. So you have t minus 60 over 2 times, and this is going to be 4v over 3 plus 3v over 3, which is 7v over 3. Okay, can I simplify that a bit? I think I can. That's like 7v times t minus 60 over 6. I'll leave it like that for now. So I know that the area of A and B is equal to the area that we got in the beginning, which is v times t minus 15. So the area moved by the car, v times t minus 15, is the same area as these two added together, which is 40v plus 7v times t minus 60 over 6. Okay, so what we can see here, if we divide both sides by v, okay, we're going to get rid of the v's from the whole equation. And if I multiply both sides by 6 to get rid of the fraction, I'm going to have 6 times t minus 15 equals 40 times 6, which is 240, plus this will be t minus 60. Got rid of this 6. Okay, so I have 6t. Oh, there's a 7 here, sorry. 7 times t minus 60. Got the 7 there, right? Be careful. Okay, cancel out the 6, but there's a 7 there. All right, so 6t minus 90. 6 times 15 is 90, so minus 90 is equal to 240 plus 7t minus 420. 7 times t minus 420. Okay, now I can bring the t's together on this side. So 7t minus 6t is equal to, and here I'm going to have 420, add 420 to both sides. I'm going to have minus 90 here already and minus 240 here. And so that gives us t here on this side. That's 420 minus 330. 420 minus 330, and that gives us 90. So t is equal to 90. All right? And there's the answer. The answer is 90. Find the value of t. Okay, so that's 90. So a bit long-winded there, but the principle is the same as most of these type of questions. In a speed time graph, the distance is given by the area under the graph. And here we have these two areas. They must be the same. So I found the area of, we already found the area of the travel of the motorbike journey, sorry, the car journey, and the motorbike journey, its area we found by splitting this trapezium, or splitting this shape into two trapeziums, A and B, and equating the areas to the area of the car journey, and we found the answer was t equals 90. And that concludes this whole of this question number 5 from the June 2023 Mechanics M1 paper. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions to do with speed time graphs can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video that will appear in this region here, which will tell you how to use my channel to find things that you might be interested in or might benefit you. Thank you for watching, and see you soon.